Hi, this is Motorized Barometric vacuum pump that I designed and manufactured. I've explained its mechanism on the side. Its pumping speed using this motor gearbox is 63 cubic meter per hour. And since air pressure here is 840 millibars, as this gauge shows, this pump lowers the pressure inside the vacuum vessel down very near to 0 millibars. Of course, we need a more accurate gauge like pyramid gauge to measure this minimum pressure with sufficient accuracy. At present, I don't intend to do such a measurement here. According to the diameter of the pistons and the longitudinal displacement of the pistons and the output rotational speed of the gearbox, pumping speed of this pump is 63 cubic meter per hour. At first I made a smaller sample of this pump and connected it directly to 1400 RPM electromotor without using any gearbox. In those conditions, with that RPM, the pump worked well, but no very good vacuum would be obtained. The reason was a severe turbulence of oil and its intense mixing with air, and so producing so many tiny bubbles in oil. These bubbles went out of the vacuum chamber and took with themselves oil out of the chambers, and so instead of it, air was displaced, and then the vacuum quality would fall. But in this pump, with the output rotational speed of 190 RPM for the gearbox, we obtain a vacuum with high or at least acceptable quality, but with the pumping speed of only 63 cubic meter per hour. Although such a pumping speed is acceptable for such a vacuum pump, with such conditions and low price, I have a strong guess that there is an optimum point between the two output rotational speed of 190 RPM and 1400 RPM, in which, while retaining high quality of vacuum, pumping speed will increase. For example, I believe that if you use a motor gearbox with double power and double output rotational speed for the gearbox and install it on this same constant basis here without any other change in the pump, pumping speed will become double, i.e. that is 126 cubic meter per hour, while the quality of the obtained vacuum will not deteriorate. But neither do I this experiment here. This experiment and the one for accurate measuring of the quality of the obtained vacuum, which, as I said, I don't intend to perform neither of them here, are among some works I like to do in a technical scientific environment with real support facilities, maybe like yours, not in my present conditions in which, with hardship and many problems, I've delivered this product at least in a form presentable to market from an early patent. There are other important R&D works doable on this pump, including its modification for use as blower. There is a short film on this site in this respect, and its modification for use as a high vacuum pump, explained on this site. Practically, no longer I'm willing and financially able to follow any of these works here. By looking at the drawings of the predominantly ferrous pieces on the side and considering open tolerances for making them and use of ordinary piston mechanism for the pump and use of the cheapest Teflon for pistons and use of ordinary hydraulic oil, you can easily grasp that the price of this pump will be observably lower than the price of any available vacuum pump in the market with the same pumping speed and reachable vacuum quality. I request you to have special attention to these matters and also to information presented on the site. And then, firstly, consider possibility of my lodging and continuing my work at your workshop, and secondly, consider possibility of your partnership in commercial production of this type of pump. Thanks.